All right. We are so very fortunate to get to have a conversation today with folks from our South Atlantic Landscape Cooperative. Louise Vaughn and Amy Keister are going to talk to us a little bit about the implications and trials and strategies to dealing with scaling issues and modeling at the landscape scale. So I am ever so grateful for these two women to talk to us today. I'm going to hand it over to Louise first.
Hi, my name is Louise Vaughn, and my role is to help people use the Southeast Conservation Blueprint, which is it is the primary product of the Southeast Conservation Adaptation Strategy. And that is a regional conservation initiative that spans about 15 southeastern states and down into the Caribbean. It covers Puerto Rico and the U.S. Virgin Islands. And my job is to really help people use the blueprint to inform their conservation decisions. The blueprint, it's our plan, it's our living spatial plan to connect the lands and waters of the Southeast. And we're doing that because we have ultimately a goal for a 10% or greater improvement in the health, function, and connectivity of Southeastern ecosystems by 2060. One of the architects of this plan that I really rely on a lot to help me help people use this plan is actually Amy Keister, my colleague here.
Hi, my name is Amy Keister, and so I do the GIS coordination for the South Atlantic and Southeast Blueprints. So I'm more behind the scenes, prepping the data and trying to get everything ready so that we can make this spatial plan.
Mm-hmm. And the way that Amy and I work together is that we always want to be consistently improving the blueprint and consistently improving the data that underlies the blueprint. And the best way that we can do that is by working with others, observing how they access the spatial data, how they interpret the spatial data, as well as how good that actual spatial data is. And so when I see a problem or when I recognize or am able to identify an issue with any of that, with the access of it, the interpretation of it, or the quality of the data itself, then I will go straight to Amy and we'll try to work on solving that problem together. I'm going to share my screen so I can actually show people what the blueprint looks like and what CCAS is. So I'm just going to blow up my screen here. So this is the Southeast Blueprint, and basically places that are in dark blue are considered of high conservation value, and places in medium conservation, or places in this lighter blue, are considered medium conservation value. And what we're basically saying is that if we work within the blue, these are the best places for shared conservation action, meaning that ultimately, if we think of the conservation community as one community, as our larger community, these are the best places to work that have multiple co-benefits. These are the best places that we can work around shared goals and priorities to ultimately get to this vision of connected lands and waters across the Southeast. You'll start to kind of notice as you stare at this a little bit that it looks a little bit different. Like notice here in Texas, it looks a little bit different than it does here in the South Atlantic region, which are these states right here. And even going out, this plan does extend out into the Atlantic Ocean a bit and down into the Gulf. And that there's a couple of certain patterns here that they're just a little bit different, as you'll notice. And one of the reasons behind this is because we actually do not want to create data. We want to draw on existing data sets. We want to promote the good work of others. We don't want to replicate anything, and we don't want to spend our time in data creation. We want to pull on the existing data that already exists from other more localized or sub-regional conservation plans, and we want to draw upon that to inform our decisions. And so what I'm showing you here is I often call the blueprint a quilt. And these are kind of the quilt squares. So basically here's the either statewide or sub-regional plans that we kind of stitch together to inform the Southeast Blueprint. You'll notice these areas here, these hatch marks, that represents places where there's overlap of multiple plans. And people like Amy are smart enough to think about how we integrate multiple plans, sometimes 3 plans, into one seamless blueprint. And so the reason we do this, as I mentioned, is because we don't want to create data. And the reason for that is with the stressors that are going on right now, sea level rise, urbanization, other impacts of climate change, things like that, extreme storm events, we need to do conservation actions now. And if we were to try to create the perfect data to inform our conservation actions, we would be out of time basically to make decisions now. So we want to use existing data. Oftentimes it's really high quality. It serves our purposes really, really well. And we want to use that and we want to promote those existing tools that we have instead of creating new tools and start working with people now. And so that's kind of the reason why we're drawing on these existing data sets as they are. But there's trade-offs with that. On the one hand, we get to act right now to inform conservation decisions. If we were to wait until we had the perfect data, we might be waiting 10 years, 5 years, and then certain opportunities that are available today would be lost to us. Going forward in the future, we will try to create consistent methodologies and indicators, still drawing from similar data sets and data sources to create a more seamless, holistic blueprint. But for today, that's not until next year, when we do a new approach where we're using a consistent suite of indicators to drive conservation priorities and conservation values. And we'll use kind of consistent approaches. But for right now, and what we've currently done to this point, is we have this kind of patchwork quilt scenario. And with that, I'm going to turn it over to Amy Keister.
Yeah, thank you, Louise. So, as Louise mentioned, our goal is to not to duplicate the good work of others. We're trying to work with existing data. And this plan, actually, we started working on this about 10 years ago. And so the idea is that we're trying to get this data out to people so they can actually try to use it to make decisions. And then they can come back and tell us if it's helpful or not. And so we have this iterative cycle where we're trying to get information and updates out to people annually, and then improve the data, improve the methods as we go along. And so it's really exciting because sometimes, in other projects, I've had that 10-year cycle that Louise talked about where I started a project and by the time the data actually hit the street, the conditions had changed. And so this is a really good opportunity to impact decisions, but it creates some big challenges. And so I wanted to show you some examples from early days in the South Atlantic subregion. So I'm going to share my screen now, just to show you a quick little slide series. So are y'all seeing a map now?
Yes.
Okay, excellent. So here's an example from maritime forest. And so maritime forest is a habitat type in the South Atlantic that is really rare, and it's been hit really hard. There's not a lot of it left. Those sites are usually highly valuable for housing developments. And so here is some source data that we had for maritime forest. You can see somebody went in and digitized this. Like we are zoomed pretty far in. We got a scale bar here showing us this is just 0.2 miles. So somebody has really went in here and digitized this very specifically. Well, when we first started the South Atlantic Blueprint, we had limitations on processing time. We weren't quite sure how fine of a resolution we could get away with. So we started off with 200-meter data. So first, when we tried, we needed to get this into 200 meters. And so the resampling technique that is commonly used is just called a nearest neighbor. So it would take a 200-meter cell. You can kind of see roughly what a 200-meter cell might look like with this. And it basically disappears if you just use nearest neighbor because there's not big enough patches for even the 200-meter cells to see it. So we had to use a different technique. We had to say, what's the maximum value in this 200 meters in order to get it to show up at all? So you can see we've really changed the scale of this data so that we could get it into the processing time that we needed. And then as, you know, it's been 10 years, we've gotten better. We've been able to process data more easily. So we needed to switch to a 30 meter. We were changing the whole blueprint to a 30 meter pixel resolution. And so here's kind of what it looks like at 30 meters. But again, we were moving really fast. We're trying to get annual updates out. And so we had 30 some indicators that all needed to be updated from 200 meters to 30 meters. And so some of them had been created at 30 meters and then resampled up. And we didn't have to do this trick to try to use the maximum value so that they would show up at all. And so some of those we could just, you know, resample back down to 30 meters and we were fine. But for this one, if we were to go from this source data to 200 meters, and then if we just resampled this to 30 meters, it would still look like this. But then at this point, the end user doesn't know. If they see 30 meters on the spatial data, they think, oh, that's 30 meter data, when really it has been distorted. And so, you know, we were moving fast. Maybe we could just resample this, and we had to stop and go, okay, we're moving too fast. And we actually need to go back to that source polygon data and do a direct resample to 30 meters. And it's still, you can see that the data does still get distorted, but it's a lot better than when we went straight to 200 meters. And so that's some of the stuff, that challenges that we're trying to work through with that combination of using existing data that wasn't perfectly created for this project, and then moving fast, trying to make sure that this data gets out and stays relevant for people. And so that was my kind of quick example that I wanted to show you. Sometimes it's so much easier to see these things whenever we look at them spatially. But we really run into this in all of our areas. Another big place is the marine environment. Like Louise showed, we're trying to go out into the marine environment, and some of that data is based on survey data. It's like 10-kilometer cells. And then we'll have other data where it's a point observation of coral, and there's probably an error around that point. I didn't get the error from the source data, so I don't know what, you know, is that point somewhere within a 200 meter radius of there, or a 5-kilometer radius of there. And so it really is challenging. These scaling issues can really get tricky, and we're doing the best we can, and we're trying to get information out to folks so that we can hear back whether it's helping them make decisions.
And one thing that we do always say is that we're creating a regional plan from some regional inputs. But even those sub-regional inputs, they're pretty broad. So in the South Atlantic states, we used indicators that were collected across 6 states ultimately in the South Atlantic region. And what we like to do with the blueprint is we kind of say, like, it's a great first place to look for conservation opportunities. Let's work within the blue. But you should couple that with local data. And there's a couple of different reasons for that. A lot of times when I'm talking to people and we'll start chatting about data, they're like, oh, I want as fine scale as possible. Like, I want to see, like, give me the 1 meter by 1 meter cell. And in my mind, I'm kind of thinking, like, I don't think you really want that, because even 30 meter by 30 meter, like, that is what, like, basically it's less than 1/4 of an acre. And so if you're thinking about management and how you manage lands, we typically don't think about really small patches. We tend to manage more for a whole, or for an ecosystem, or for a parcel, or something like that. And the finer scale your data, the bigger it is, the longer it takes to work with, and sometimes even, like, the more errors are likely. And so we do need to get to a point where a lot of times when people are trying to make conservation decisions, where it's better to use local knowledge and data with larger data sets. So instead of, like, if you looked at the conservation blueprint and you zoomed into an area and you were, like, trying to figure out, do I work on this side or this side, and they're both in the blue, you want the opportunity to kind of look underneath the conservation value itself to see what's driving that. And then also that's a great opportunity to work with kind of more local data sets without trying to kind of, as Amy said, like, let's take these local data sets that were created for the specific purpose and blow it up across the landscape. That's not going to work, and you're losing some of the integrity of the data when you do that. But if you take these regional data sets and you try to dive underneath them, and then you couple that with looking at local data, talking to people and looking and thinking about local expertise, that's really going to help you make a better decision than using just one or the other data set. Mariah, do you have any questions for us?
I do have a question or two, and you guys, this is such great real world discussion and examples on this topic. I'm curious, and I think you sort of just addressed this, Louise, that what do you feel like is the most appropriate scale of sort of conservation action to use the blueprint? Is it in defining conservation areas rather than maybe, making really fine-tuned decisions in a forest management plan at a parcel level?
It depends on who you are and what you're trying to accomplish. A lot of times what we're doing with people, like a common blueprint request that we get is for applying for funding, for grants, for acquisition, restoration, management. And a lot of times what the blueprint can do is it can help tell a story about your landscape. And I guess one example of that is I was working on one project down in Florida, in the Florida Panhandle, and they were going after a big funding source. And one thing the blueprint could do is say, so keep in mind that the blueprint is the primary product of CCAS, and CCAS is basically a conservation initiative, which means that we are all working together to come up with areas like, what is our shared priorities? Where does the Fish and Wildlife Service and the Army Corps of Engineer and local land trust and tribes, like, where do they all agree on? And so that's what the blueprint can say, is saying, like, this is an area that is considered by the wider conservation community of having conservation value. The reason for this prioritization is driven by these specific indicators, these specific data sets, and that can kind of help tell a story of they have really intact, high quality natural riparian buffers along the rivers. It's part of an intact habitat core, meaning that it's an unfragmented, highly natural landscape. It has great biodiversity value if we look at what TNC's resilient terrestrial sites has to say about that. So basically what we're doing is we're telling a story about why this place is important on a regional scale. And then a lot of times local knowledge can help complement that by saying, and this is why it's important locally. Maybe it has this very endemic species that only occurs here. It's important locally, it's important regionally, and this is why we should all work together, give these people the funding, because this place matters for multiple strategies at a local scale and at a landscape scale. And that's really what the blueprint does very, very well. It can also help if you're thinking about, if you're an organization that wants to partner with other organizations, the blueprint can help you do that. And the scale kind of depends on what decisions you're looking to make and what the scale of your action ultimately is. If you're trying to choose between two parcels, the blueprint can only take you so far because that's a very fine scale decision depending on the parcel size. So it just kind of depends, which is, I don't like that answer. I find that that's the most common answer in conservation is, it kind of depends on the context.
I've used the blueprint for the very situation you described, Louise, to really run some analytics to be able to talk about how a parcel, like a 2,000 acre parcel, fits into a larger landscape and the context and importance of that landscape at the regional scale. Amy, I'm wondering if you want to talk a little bit on the particular challenge of forecasting data where we look forward, climate change, all these forces that we're dealing with that pose challenges for conservation and how that gets incorporated and scaled?
That is a really interesting question because it's challenging in ways that I didn't necessarily anticipate because I knew it would be hard, like predicting the future. That's not going to be easy. But then when we started doing some testing early on in the South Atlantic, we found out that even if you have predicted the future and think you know what's going to happen, so sea level rise is going to happen here, what should we do? Depending on who your partner is, they're going to want to do different things. So if you're working with somebody who just says, you know what, I don't want to mess with places that are going to be impacted with sea level rise. I'm going to be working inland. I'm trying to build these terrestrial sanctuaries. They'd say, tell me where sea level rise is going to happen. I want to stay away from there. If you're working with people who are doing things like oyster restoration or marsh migration, they're saying, I want to know where sea level rise is so that I can go there and put my conservation dollars exactly in that area. And so at first, when we started with the blueprint, we assumed like, okay, we'll find out, we'll work with NOAA, we'll get these estimations of sea level rise, and we'll just make those not priority because they're going to change. But then when we started talking with partners, they're like, no, that's the place where I want to be. That's the place where I need to help mitigate that change. And so it's challenging as far as forecasting, but it's just as challenging as far as working with partners and finding out what their priorities are. So that was a surprise to me.
Yeah.
That is such an interesting example. Well, any other final words of advice for ecologists that are going to be coming into the workforce and just, I think about the explosion in data and tools available in my career over the last 15 years. I think more and more we're able to try to make informed decisions using remote sensing data. So I was going to give you guys a little window for final words of wisdom.
I think there's a lot of data and tools out there. So now whenever I'm working on a project and somebody's like, ooh, let's create something, I always want to pause and stop and look around and make sure that it's not already available. And if it is available, but it's not quite what we need, to really think about the trade-off of the difference between if we waited to build the tool that would be perfect for us, what would we gain and what would we lose by that? And I think that's really kind of important because especially ecologists, biologists, landscape level modelers, we're a high science community. There's a lot of scientists in the community, and people love to create science. But it's really equally, if not more important, to think about the way people will use those data products and the science. There's a lot of issues when we create science, how we're disseminating that to the public, especially if you think about it publicly funded, it should be able to be consumed by the public. So thinking about where you host that data, how you announce that data, and how you communicate that data, it's going to be really, really important, especially if you want the most people you can to take action on that data. If you think you've got a high quality product that can really serve conservation, I fully believe that you have a responsibility in how you communicate that and how you get people to use it. And positions like mine that are really focused on helping people use information and not kind of getting away with the assumption of like, oh, here's a lot of technical scientific information. I'm just going to expect everybody to be able to absorb this and make a decision. My position is more of like, no, I'm not going to have that assumption for you. I'm here to help you. I'm here to help anybody use this information to make a decision. And I think that's really valuable. I would also throw a question to Amy about, I feel like we've talked a little bit about, we use this data, it's not perfect. Sometimes it was at different scales. We've worked with it all together. We did that because of the trade-off. Sometimes I'm interested, and one thing that I really appreciate about Amy is like, when do you pump the brakes? Like, when do you say like, don't do that? Like, now we've gone too far, we're doing more harm than good. And I would be curious about that.
Yeah, so for that, it's, I would say kind of like be cautious but not terrified. Like always be afraid that you could really mess something up, but don't let that paralyze you to the point where like I'm not going to try anything ever. And so the things that I really watch out for is that example I showed where it's like you have source data, it's resampled, and then you trying to bring it back down. Like you definitely don't want to go up and back down. You want to go back to that original source data if you can. That's the main thing that just rings major alarm bells for me. And so that kind of leads me into my major takeaway, which is data management. And it's not a fun topic, but it is essential because we're working with data. And a lot of times you'll talk with folks and they're like, oh, I know somebody that did a paper on that. There's all this data out there and the data doesn't exist. Or if it does exist, it's not documented. So it's not documented in a way that I can go back and use it. Or it's like, well, this model ran 6 open pine bird species. I can guess which those species are, but I'd really love to know. And so it's something that we haven't paid attention to a lot, at least in conservation that I've worked in before. Like you get all excited, you get your project done, and then you get funding for another project. So you got to move on. And we're struggling with it in the Fish and Wildlife Service. I think everybody struggles with it. And so we need to write our metadata. And then we also need to have data managers. We need to have infrastructure around data management and conservation that we haven't had in the past. And so, like Louise said, we don't want to have to go out and resample for Bachman Sparrow every year because we just lost the one that we did last year. So, yeah, that would be my takeaway for anybody getting into this work is commit to data management, commit to writing your metadata, make this data usable for your project plus future projects if you can.
Yes. And that, I mean, to your point, like I'm a qualitative researcher by training. I like to follow birders out in the field. I don't really know my birds. And so when I see something that it's like, here's 6 pine birds, I really have no idea. I don't know. And so if that documentation's not there, I can't even begin to communicate that to somebody else or why they should care about 6 pine birds. I actually need somebody to tell me why. I'll and take that technical information and try to run with it for people. But so many times I've downloaded data sets and just thought like, I don't know what I'm looking at. I have no idea what this is. And at least Amy can guess. I'm really left in the dark. So.
Well, I have noticed you guys do an incredible job with all your data sets. You know, you make available to the community all of the pieces and parts that roll up to make the blueprint. You explain a lot about how that data was gathered, at what scale it was processed, and that is such a huge value to the conservation community and the scientific community. So thank you, Amy. That must be your imprint on that.
We're trying and we're learning as we go. Like we've not always, we're improving as we go. So commit to improvement as well.
Awesome. Well, thank you guys so much. And I so appreciate your time today, and we can wrap her up.
All right.
Thank you.
I'm gonna stop recording.